Awesome. Thank you, Ashley. So let me start here by sharing my screen. Thanks everyone for joining our session today. I'm going to be speaking about the Zero Trust web application security with Azure WAF, Azure Firewall, and also DDoS. My name is Saleem Bseeu, and I have with me my colleague Andrew Mathu. So let's go over the agenda for today and what we will be specifically going over. We have the first. I'm going to go over the services that will enable you to have the best or most complete zero trust on the Azure, and then I'll go over some of the services like DDoS, Firewall, and WAF to explain a bit like how they work together, and then on the setup. In the setup, there's the specific topology that we used for our inbound TLS inspection and IDPS, and then the routing, how it works, and also the certificate, how we have it managed. From there, my colleague Andrew Matthew will take over, and he will show you in the demo how to configure it in Azure and how to have it correctly set up. Please use the feedback form if you have any feedback about the product specifically or the session. If you think that there's something that should be improved, something that's missing, or from your own experience, you can use it. So let's start first with the approach. So zero trust approach and the services we have in Azure that will help you enable it. As you can see here, we have around 5 services or 5 groups of services, and they're split into segmentation, application protection. Let's start over with the VNet integration. You can use either VNet injection, private link, or service endpoints to restrict access to Azure service resources, to specific virtual networks that you have. Then we have the NSGs, network security groups. So NSGs, you can use them to have specific rules to filter or deny or allow layer 3 and layer 4 traffic based on the direction and the IP that you have. Then we have the Azure Firewall. The Azure Firewall, as you notice here, it's in between segmentation and application protection. The reason is because the Azure Firewall has IDPS, has other security features, which is part of the application protection. Then it also has segmentation. You can configure it in the hub and then specifically allow certain traffic to certain destinations, VNets, or your V1. And then we have the Web Application Firewall, which is the WAF, which is the layer 7 protection from common exploits and vulnerabilities. And at the end, we have the DDoS protection, more specifically DDoS standard protection plan, which I'm going to talk more about later, which is kind of the last layer of defense you have. And let's have a look at the different layers. And this is a good way of looking at network security from Azure perspective, where, as you see in the middle, you have there the Azure deployments, and from the outside we have the internet, and from there we can also have attacks happening from the internet and going inside. And looking at the different layers, we have the first layer, or at least at the edge, we have the front door with WAF. So as you know, the front door is at the complete edge, and with the front door, which is layer 7 global load balancer, you can also enable WAF, which will provide you with layer 7 protection against common attacks like SQL injection or cross-site scripting. And then we have after that the DDoS protection. DDoS protection is enabled on your VNets, and it will give you the configuration for DDoS protection, or the standard is probably the most simple here. We're enabled on specific VNet, and it will protect your public IPs from DDoS attacks at layer 3 and layer 4. Then after that, we have the virtual network isolation. So you have your VNets, you have the VNet peering. You can segment it on the way you want, depending on the security level of the applications you have net VNet, and that goes hand in hand with the Azure Firewall. So the Azure Firewall and specific deployments, and the most common one is the hub and spoke, where you place the Azure Firewall in the hub, and using the Azure Firewall, you will segment the traffic, and at the same time, you can enable TLS inspection, IDPS inspection, URL filtering, and also web categories for security purposes. Then we have the application gateway with WAF. The application gateway with WAF, in this case, we've placed it after the Azure Firewall. It can be placed also before. Depends on your needs, on what specific type of deployment you have. So the application gateway, which is the regional load balancer, and we have the WAF enabled on it, which is the web application firewall for layer 7 types of attacks. And then we have at the end, the NSG, ASG, and your routing, which will also add the segmentation and extra security. And this is a more of a simple view of of the available services and how you can protect against networks against different attacks, and how to have a more let's say zero trust approach, which in this session actually I will go deeper into, and how to have it properly configured. Before that, I'm going to give you a quick overview of the services which I will speak about, and that's WAF, Firewall, and DDoS. I'll start first with DDoS. So not to confuse the Azure DDoS Protection Standard with the basic, or now it's renamed Infrastructure DDoS Protection. The basic core infrastructure is there to protect the Azure resources. Azure DDoS Protection Standard is there to protect your specific resources, and it uses adaptive tuning for that. So the plan, or the standard plan, Azure Global Network, which basically means it's global. You enable it on your specific tenant, then you can have it on all the public IPs in that specific tenant. The mitigation is done globally from the source of where the packet is coming from and entering the Azure data center. Then we have the adaptive tuning. The adaptive tuning is based on each public IP you have, and what it does, it will set specific thresholds for each public IP you have, and it will base it on the type of traffic that's coming in, going out, and also the scaling that's happening behind it. So we'll have a specific threshold for each public IP when the mitigation to start. And of course, since it's a native service, we have also the attack analytics. So you can look at the logging. We have workbooks which you can look at specific, where the attacks are coming from, which types of attacks you have for DDoS, and then the metrics. The metrics you can see, for example, when was a specific public IP under attack, what's the threshold we have for each public IP, and to troubleshoot it. And then, of course, speaking about troubleshooting, we have the DDoS rapid response team. So with this plan comes also this specific team which you can engage, and they can help you with investigation, or if you're doing some specific change. Then we have the SLA guarantee and cost protection, which of course also comes with the DDoS standard. For the next one, we have the Azure Firewall. So I'm not going to go very deep into the specific features of Azure Firewall, but as part of zero trust and security, I will speak a bit about the built-in high availability and auto-scaling. So Azure Firewall will always, when you deploy it, will always have at least 2 instances, and it will auto-scale up from there. So you will always have some type of redundancy. And of course, with the Azure Firewall, then you can have network and application traffic filtering, centralized policy across VNets and subscriptions. Then from there, you depending on the deployment that you have, if you have, for example, spoke-to-spoke, hub-to-spoke, you can have a complete VNet protection where all the traffic goes through the Azure Firewall to the internet, to on-premises using VPN or using express route, or also you go into your, for example, private link. Then we have centralized logging, which you can use any SIEM if you want that you're using, or you can use Sentinel or Event Hub that we have. And then, of course, all the other integrations with Microsoft Defender for Cloud, FQDN tags, integration, and other backup in Azure services. The specific services that actually I would like to speak more about for this session, since we're speaking about zero trust, is the TLS inspection and the IDPS. Now, for this session at least, we want to show you how to have a complete end-to-end TLS encrypted traffic and have IDPS inspecting that traffic. So, which means that decrypting it and checking it for layer 3, 4, and also 7, and we will also have DDoS protection. So, from the Azure Firewall point of view, there's the built-in TLS inspection for outbound and east-west traffic. Outbound means like any traffic that goes to the internet. East-west is traffic going from Azure to Azure, so all of it inside. Then we have the inbound TLS termination, So inbound is the traffic coming from outside of Azure to Azure. And for that, we will use the Azure Application Gateway. And later, I will tell you more about why we're using the Application Gateway for the inbound. And of course, you can use the Azure Key Vault integration, which actually in our case, we will be using to manage the certificates. So using the TLS inspection, once we decrypt the traffic, the TLS traffic, we then use the IDPS. So the IDPS Azure Firewall has, I think, now more than 60,000 signatures, which it will check against malicious traffic, any traffic that is irregular, or anything that it looks as suspicious traffic using the signatures that we have in the database. And of course, it will look at it. Our signature base is, it's updated daily by we add 7 to 10, I think, new signatures every day. So it's being continuously updated, and using the also TLS inspection, we can check all the traffic. Two other services which I will not speak too much about for this session because we are focused on the TLS and IDPS. Is we also have URL filtering and web categories, and that's also included with the Azure Firewall premium SKU. And for this specific scenario, we will actually use the premium SKU because of the extra security features. The Azure Web Application Firewall, which is WAF, on the application gateway in this scenario, because we will be using the application gateway for inbound traffic. It provides, of course, the application gateway with high availability, auto-scaling, and fully platform managed, so you don't need to do any updates. It's a cloud managed service. It's also, supports public IPs, private IPs, cross regions. And then we have the WAF. So the WAF provides OWASP top 10 out of box. And we have the latest, actually, CRS 3.2, which has been out since, I think, 3 months now. And with that, we have also new engine. So more new with new rules and new rule set for extra protection against most common attacks. And then you can also add rule configuration, exclusion list. We have also the anomaly scoring and different specific exclusions you can add to your WAF. And then, of course, we have the monitoring, alerting, and specific integrations with the Sentinel, Microsoft Defender for Cloud, and also workbooks that can help you, with looking for specific attacks and, finding out if it's a real attack or if it's false positive. And that's for the WAF application gateway. Now, the three services that I've mentioned, we will be using them all together to have the full security or full network security and zero trust concept. And I will go over the topology and the setup that we're using in this case. So in our case, as you can see, for this specific session, we will have first, we will have the DDoS protection. As you can see, it is around the VNet. So all the public IPs you have in this specific VNet are protected with the Azure DDoS protection standard, and gives you volumetric and also protocol layer 3 and layer 4 protection. The traffic, as you can see here, in this case, comes from the internet and goes to our web application, which is in the spoke virtual network. So after it goes through the DDoS, after DDoS protection, we have the application gateway with Azure WAF in that case. So we have there the layer 7 protection. Layer 7 protection will provide you, as I said, like protection from OWASP layer, like cross-site scripting, SQL injection, different type of layer 7 attacks, and then from there it will go to our Azure Firewall. The Azure Firewall will provide also protection at layer 3, 4, and 7 for using the IDPS and using other rules that you have set there. And from there, it's sent to our virtual machine. Now, in the topology itself, what you will notice here with the red line is that all the connection is encrypted. And that's the reason why you see down there the certificates, which I'll speak about in a bit. So from the client, so from the user, from the computer user, when they access that website, all the connection will be connected, or all the traffic will be under TLS encryption, and we will have 3 points where it will decrypt them and then send it back. Going into a bit more details about how we configure the routing, which in this case, in our topology, is quite simple. We have the first route table on the application gateway, or the subnet where we have the application gateway with Azure WAF. The route table there will send, we have the destination as the Azure Firewall, which is 10.8.1.4. It will send all the traffic that it receives to the Azure Firewall. We added this route table route because otherwise it will send it directly to our VM, which we don't want that. We want the traffic to be inspected by the TLS and also IDPS. Now, the reason why we're also showing here just the private IPs, just to let you know, the application gateway and also Azure Firewall both have public IPs, and the Azure Firewall you can also configure it without using forced tunneling, but in this case we will be focused on the private IPs because that's what we will be using inside Azure. Now, once the traffic is sent from the Azure Firewall to our virtual machine subnet, which is the web server, once it sends it back, it will switch the destination and also the source. In this case, the destination we have here, the source we have here is the application gateway IP. And the reason is because on the Azure Firewall, by default, it will not do SNAT, it will not source NAT the traffic that comes from a private IP. And in this case, the application gateway we will be using a private IP. So once it switches the destination and the source, in this case, we have that specific route, as you can see down there, which will send the traffic to our Azure Firewall. Otherwise, it will send it to the application gateway, and we will miss a point there. So it will send it back to the Azure Firewall. The Azure Firewall will pass it through the application gateway and to the internet. Now, as you can see, we also have a default route there. The default route there is for the connections that start from the web application. So in case you have outbound connections, then they will simply just use the Azure Firewall. And so with these two route tables and 3 routes, we have the simple topology for our HTTPS settings. Now, speaking a bit more about the specific certificates that we're using here, and as you will notice, we have around 4 certificates. The first one, which is the certificate and HTTPS listener, which is configuration done on the application gateway. And my colleague Mathu will go into more details about how to make this configuration and how to make this topology to help you if you're trying to create a zero trust setup. So the first connection, right, is from the user to the application gateway. We will be using, in this case, a certificate which is signed by a trusted CA, which in this case is the DigiCert. And we'll be using the common name, which, as you will notice, it will be the same also on the Azure Firewall and also on the web server to make it easier for the traffic to be sent out to the web server. Now, of course, if you're not looking for a zero trust kind of approach and you just want an HTTPS connection just from the user to the application gateway and have this not encrypted when the traffic is in the Azure, it's very easy to do. You just have to configure the HTTPS listener with a certificate and have the backup, the pool which the application gateway has with the servers without the HTTPS settings. So just HTTP, and that's easily, very easy configurable. But in our case, we want to have the traffic going through Azure Firewall, and we want to use the TLS inspection with the IDPS for full security with HTTPS. That's the first certificate we have, and of course we always use the certificate which is signed by trusted CA since it goes over the internet. The second one, we will use the Azure Firewall route. The Azure Firewall route, in this case, it's generated in the Azure Firewall itself. Andrew will show you later how to generate it in the Azure Firewall, and we will use that certificate as a custom route CA in the HTTPS settings on the application gateway itself. And then, like, that's the second certificate. And then the next one is the root or the self-sign that we have here. Self-sign certificate we will use in the Azure Firewall. Will have the CA name of Azure Firewall root, because otherwise the application gateway will not see the connection as healthy and it will drop it. So we will need to be using the same CA. And some explanation about why we're using these certificates and why we're not simply using just one in the application gateway. And the reason for that is because the application gateway is a reverse proxy, while the Azure Firewall is a web proxy. So it only has one direction. And some a bit more explanation about that. So the application gateway, as I said, works as a web proxy. So it protects the server configured in the backend pool using IP or FQDN, while the Azure Firewall works more as a web proxy. So it will imitate, or it will impersonate the target web server by generating certificates and also presenting them to the client. And so in this case, that's why we'll be using the self-signed certificate, which it will present it, and the application gateway will trust it and send the traffic over. Now, for the last step, or the last step of the configuration we have here, which is the Azure Firewall to the web server, the Azure Firewall will create another TLS connection to the web server itself. And of course, on the web server, we need a certificate signed by trusted CA, because otherwise the Azure Firewall will not accept the connection. And that's the reason why we need also to use one here. And from there, it will the web server will decrypt the traffic, and of course, after it finishes with the application controller, it will send it back. It will go the same way. Now, this configuration may seem a bit complicated, and the reason why is because we have a few checkpoints. Let's say here, application gateway with WAF, Azure Firewall, IDPS with TLS, but at the end, it gives you full zero trust, and all the traffic is encrypted all the way end to end from the client to the web server. So this is not the end. So my colleague Andrew Mathu will show exactly how we did it in the lab, and we'll give you more information. And of course, we will also be hopefully soon creating or publishing a new blog, which will show you step by step how to make this configuration, and a little bit more explanation about this. I would like to give the floor to Andrew.
Thank you, Saleem. Hi everyone, my name is Andrew Mathu. I'm a program manager in the network security CXC team, and I'll be taking us through this demo session. So for this session, we'll go through an overview of the setup that Saleem showed, and then we're also going to do a small attack simulation just to test that this setup works. So to begin off, I'll start with the DDoS protection. Like mentioned, we have DDoS standard protection running in our hub VNet. So we have associated it with the hub VNet. And this is where the application gateway public IP address is located. So of course, DDoS standard, you're able to stop DDoS attacks, volumetric, protocol or resource based. So this has been attached to that main hub VNet. Moving on, we have the application gateway. So this is the first point of contact when a user wants to access our web application. So this application gateway has been configured with WAF version 2 to stop layer 7 based attacks, application attacks, or OWASP based attacks. So in terms of the configuration, we have the web application firewall, WAF here called WAF test TLS, which we have currently set in detection mode, but we can also do it in prevention mode. We'll do that in a bit when we do the attack simulation. For our backend pool, we have two pools, one for HTTP and HTTPS, and the HTTPS pool is the one that is of interest to us. So within this pool, we have defined the FQDN of our web application. So it's called netsecapp.build.sexxp.ninja. For our backend settings, which defines the behavior of the routing rule, it also includes the port and protocol that you want to use in our backend. You can see this is how it has been configured. So we're accessing this web application through port 443, which is HTTPS. And here, as had been mentioned, this is the root certificate from our firewall. So this will ensure this trust between the application gateway and the firewall. And this is defined now by this root certificate, which we extracted from that firewall and enabled it here. So within the backend settings, you also define your connection running, your cookie-based session affinity. Then we also configured the listener, and this is the logical entity that will check for the incoming connection requests. So in this case, we have a listener for HTTP and HTTPS. So if we go to the HTTPS listener, we'll see it's been defined for port 443. And we also have the front-facing certificate. So this certificate has been signed by a well-known CA, so that when users are connecting to our back-end web application, they do not get a certificate error. And I can actually show you that here. So this is our back-end web application, configured it on Windows Server using IIS. So if I am to go to the security settings, check the certificate, you'll see that this certificate has the common name based on our backend web application, the FQDN. This is build.sexxp.ninja, and it's been signed by a well-known CA. So this prevents users from getting certificate errors. And finally, we have the rules, and the rules bind our backend targets, the backend pool, the backend settings together with the listener, and they'll define how now that traffic is going to go to our backend application. So this is now the configuration on the application gateway. When we go to the web application firewall, like I mentioned, this will provide prevention, also provide detection against application-based attacks, and we can set it into prevention mode. So this enables us to stop any attacks going to our backend web application. And then just to go a bit into something else we wanted to show is in terms of how the setup has been done. So if we look at our routing rules, we have the rules that now enable us to route traffic directly from the application gateway and make sure it goes to the firewall. So we have the route tables here, and within that we have the route. So here, this is the route that goes specifically to the back-end spoke, which has the our web application. And then from the web application part, for that return traffic, we also have the routes configured for it. So we have the default route that was mentioned, and also have the route going back to our application gateway subnet. And this goes through the firewall. So this ensures the traffic always goes through the firewall and is filtered by the firewall. When we come to the firewall section part of it, like was mentioned, the firewall contains the IDPS rules and also the TLS inspection. And this, of course, will enable it to decrypt traffic, be able to scan it and stop any threats in real time. So if I begin with IDPS, we set our IDPS to alert and deny. And this, of course, will be able to stop any threats based on the signature rules that we have. In terms of TLS inspection, we need to enable TLS inspection, and this is where you do it from. So it's a very easy setup to do. You'll enable TLS inspection, and then you need to put in a certificate in your key vault, which is associated with a managed identity. So you can see here our certificate is called server sat. Our key vault is called AZFW TLS test key vault, and then our managed identity is the AZFW test TLS. So this enable TLS inspection within the Azure Firewall. And if I was to go further inside that key vault, just to show you how that certificate has been defined. So this certificate, we created it and signed it for our web application FQDN. So you'll see here the details of this certificate. So this is the domain that we want to protect, the build sexxp ninja. And the issuer was actually ourselves, a self-signed root CA. And this certificate, you can actually be able to configure self-sign by yourself. We can also share some of these links on how you can be able to do that. The reason we did that is so that you could be able to define this FQDN, this domain, and be able to protect it. And then, of course, this is an intermediate certificate now running within this key vault and attached to our firewall. And then this root certificate, the actual root certificate is the one in the backend settings of our application gateway. So this ensures trust between the application gateway and the firewall. So this configuration, we are able to scan HTTPS or encrypted traffic, and we can see that further within our application rules. So we have here an application rule that allows traffic from the outside through the application gateway, through the firewall where it is decrypted, and it reaches our backend web application. So you can see here we've defined our source IP address to be the application gateway subnet. This is a private IP address. The destination type is FQDN, and this is the FQDN of our web application. And to enable TLS inspection in application rule is very simple. You just click here TLS inspection and you define the protocol as protocol 443. So with this firewall is able to decrypt traffic and be able to apply IDPS to stop any threats within that application traffic. So this entire setup now enables end-to-end TLS inspection both on the application gateway and also on the Azure Firewall. So what you're going to do in this next step, we're going to simulate an attack to our web application. And the first simulation is going to be at layer 7. It's basically a path traversal attack. And this happens by adding illegal characters to the end of our web application URL. So I already have another window opened, and I've appended these illegal characters here. You can see starting with the question mark, the file, and then ending with the PDF. And currently, our web application file is set in detection mode. So we want to be able to see this alert, and then we'll change it to prevention mode to prevent it. So if I refresh this page again a couple of times, you'll see it's still going through. I'm still able to get my web application main page. And if I go to the web application firewall logs, I'm just going to run this. And we should be able to see the new logs corresponding to the type of attack that we want to carry out. So I'm just going to run this again. And you can already see here some of these logs are telling us that this is an invalid character in the request. And if I open this last log up here, I'll be able to see in the details here that this request URL, URI, is actually corresponding to the type of attack that I was simulating. So it's already been detected by a web application firewall. So what I'm going to do next is I'm going to change this from a detection mode to prevention mode. And this should take only a couple of seconds. So now we are currently in prevention mode, and I'm going to run the same attack again. And you can see automatically that access is forbidden. So already the web application firewall has detected this as a malicious attack. And still, even though it's HTTPS, it has been forbidden from going any further. And if I go back to my logs and run this again, you should be able to see the actual block that triggered and was able to block this. So if I go here further, looking for a block 403, let me just run this again. Should be able to see the actual block that occurred. You can see our invalid characters here. And this is what we wanted to catch. And of course, the rules have kicked in and blocked it. So you can see when it comes to the anomaly score, it exceeded the anomaly score, and that's why the block kicked in, and we were able to get this particular message, the 403. So this proves that our prevention is actually happening, and we are able to see these logs as they come in. So the web application firewall has actually taken effect. So anything else I see after this, you can see here again, the same characters that I'd put in, it's been matched and it has been blocked. So that's the first line of the defense when it comes to our zero-day protection, or when it comes to defense in depth based on the zero trust. So the second test I'm going to do, this is now on the firewall testing IDPS. So we have IDPS enabled here in alert and deny mode. And this test, we want to see IDPS decrypting the traffic that's coming in through the web application, HTTPS. Once it decrypts it, IDPS is going to set in and be able to block that traffic in real time. So how we do this is through running from my CMD command here on my desktop. We are just going to run this command. So this sends an illegal user agent called Hexamen over HTTPS targeting our web application. So I am going to run this, and then in the logs, just to refresh this for the IDPS logs. You can see already it's not going through. So if it had gone through, they've been able to see elements of our IIS web page. So currently this means it's being blocked, and we can also be able to track this within our logs. So I'm just going to give it a couple of minutes, and yes, so you can see here these last logs around 1 minute ago when I initiated this simulation attack. This is our web application gateway private IP address 10.8.2.6. Our destination IP was our web application. You can see at the destination port 443. So this is actually encrypted traffic. So our firewall was able to decrypt this IDPS set in and was able to block this traffic. So actually the action is dropped, and you can see the suspicious user agent called Hexamen. And this is the attack that I was actually initiated. So this proves that, of course, the IDPS is working with encrypted traffic and is able to drop. So this entire setup end-to-end assures us of protection with zero trust, protection with defense in depth, and using TLS inspection in firewall, we are able to actually see any traffic within encrypted traffic. And we know that majority of traffic in the internet these days is encrypted. So this gives us a very good protection. And you can see here how it works with firewall and with the application gateway running WAF. So with that, we've been able to show this setup, how it works, both on the firewall and also on the application gateway. We've been able to stop those attacks. And the setup, like Saleem mentioned, it can look complicated to begin with, but with the right setup, you're able to route that traffic from the application gateway to the firewall, which does its own inspection, and finally, it's going to reach the backend web application, which we are protecting. And with that, this is the overview of the entire setup. And I am going to stop there and go back to the main presentation and then open it up for any question and answers. Please feel free to put it in the chat also, so that our team can also be able to answer it. And also, if there's any unanswered question, you can be able to take a look at it. Thank you.
Thank you, Andrew. Let's see if we have any more questions in the chat. The Q&A team has done a really good job answering them. Okay, so we have the first question here. Let's see. In Hexerman demo, we are seeing OWASP rules in AppGW, blocking traffic in curl output, and then also Azure Firewall showing that in its own logs.
So just repeat the question again.
In the Hexerman demo, we are seeing OWASP rules in AppGW blocking traffic in curl output, and then also Azure Firewall showing that in its own logs.
Okay, correct. So thanks for that question. So since this traffic is going through HTTPS, and the first point of contact is the application gateway has WAF, so it's also going to detect that Hexerman attack. And then also the IDPS running in the Azure Firewall. So once the traffic is decrypted, the IDPS sets in and is the one that actually does the drop, because now it's working at layer 3 and also at layer 4, where this Hexerman resides. So yes, it's going to be picked up in the application gateway. It's going to go to the firewall, and the firewall is now going to do the actual drop using the IDPS. So it's going to appear in both.
Okay, thank you. And the next question, can we use Azure WAF in place of front door?
So the WAF can be enabled on the application gateway or front door. That depends, of course, on the type of setup that you have. The application gateway is a regional load balancer, while the front door is global load balancer, right? In this case. So depending on the setup that you need, the requirements, you can use, you can enable WAF either on the application gateway or front door service. I hope that answered the question.
Maybe Ashley's on mute.
Sorry about that. Okay, the next question is there any application layer DDoS protection, and where is it configured?
Yeah, so I can maybe also answer this one. So currently the Azure DDoS standard protection or plan gives you the layer 3 and layer 4 volumetric and protocol attack protection. Currently, we don't have layer 7 DDoS protection. However, on the Azure on the WAF itself, once you enable the the OWASP rules, then you get also layer 7 protection. And more to that, we have the rate limiting available on the front door, which also can act as a DDoS protection for the front door. However, just using the standard DDoS in this case will not be enough. So in that case, that's why we have the WAF also after the DDoS standard to prevent any of these attacks.
Thank you. And when using Key Vault to store the certificates, where should that Key Vault reside in a cloud application framework setup? In the connectivity subscription or in the identity subscription?
Okay, that's an interesting question. Connectivity subscription or identity subscription? Let me answer that from the perspective of our setup. In our setup, we were using just one common subscription, which is of course linked to our environment. And then we had both the Key Vault, the managed identity running in the same resource group. However, setting up the Key Vault managed identity in terms of resource group, that should not be limited. In terms of the correct subscription, I don't have a definite answer for that, but I believe if within the same subscription that you have your production environment, that should be sufficient.
And next question. It's a follow-up question on Haxorman. Is it expected that application gateway with WAF in prevention mode will stop traffic there and not send it back to Azure Firewall?
So from a Haxorman perspective, let me try and also clarify on that. So that one was to show the firewall stopping the threats at that's at layer 4, where the firewall now resides. So after doing the decryption, IDPS is going to kick in. So now firewall will stop the threats at the layer 3 and layer 4. Well, the application gateway stops threats at layer 7. That's application and web-based attacks. So in this case, the application gateway is also going to recognize this as a potentially bad malicious user agent. But then after identifying that the actual stopping of the attack happens at the layer 3, layer 4, and that's on the firewall side. So that's why the firewall was the one actually dropping the Haxorman. For the first attack type we had done, that was an OWASP-based attack, and that's at layer 7. That's why the web application was able to stop it. I hope that clarifies it.
Okay, thank you. And does this setup work with Azure AKS with TLS inspection?
So for Azure AKS TLS inspection, we haven't yet tested this out. I don't know if Saleem, you have anything on that?
Yeah, so as far as I know, Andrew, I think it does work. I'm looking actually now for some documentation. I think recently we've documented a setup specifically, for the Azure Firewall with AKS. Let me look for it, and I can also, share it with you. Share it with the community here.
Thanks.
Okay. Let's see, we have another Haxorman demo question. In the Haxorman demo, the source IP was the app gateway. Where would you identify the original source IP, your workstation, where the attack was launched from?
Okay, that's a good question. So like in the setup, like we mentioned, the connection between the application gateway towards the web application, that's going to be the private IP address. So from the perspective of the web application, it's receiving the request from the application gateway private IP address. However, in the application gateway logs, you can be able to view the actual client that started the connection. So as an example, if I run within my browser to see my public IP address, you can just type my public IP address and you'll be able to see it. if you go to the application gateway logs, you'll actually see the public IP trying to access the FQDN. So that's where you're able to see the actual source client. I hope that's able to answer it.
Yeah, maybe something just to add here, Andrew. So the application gateway, when it does the SNAT, it will rewrite the HTTP header, and it will add there the X forwarded, header, which will have the source IP there. So you will still have the source IP when you use the application gateway in front of the Azure Firewall. So on your web server, you can see the source IP from where it was coming from. And adding to this, I see some other questions. Somebody asking why not having the Azure Firewall in front of the application gateway, and this is the reason, most used reason why we don't do it, because the Azure Firewall, when it does the SNAT, it doesn't modify the it doesn't add the X forwarded header, which in that case we will lose the source. So using the application gateway as an inbound connectivity or first point, we will always keep it, and then we will have it in the logs. Just for clarification.
Thank you. And the next question is, I saw the reply about logged WAF matching rules. This is more verbosity than AWS offers. Where can I see which headers the WAF looks at and which it does not? How about for traffic that the WAF doesn't react to? Which verbosity is logged for this in the WAF?
I'm not sure. I'm not sure I understand the question correctly. So are we asking if we can see all the logs for the WAF, like all the traffic, like going through it? Or maybe Andrew or Sumaya Kunjan, you might understand the question better. You can answer it.
I'm not sure.
Yeah, I'm also trying to look at the question. Since there's more verbosity than AWS offers, where can I see which headers the WAF looks at and which it does not?
I am gonna try to post some of the content types that we currently support. It's currently published in our documentation. I will share the link to as a response to that question. I hope that helps as well.
Okay, that sounds great.
Thanks.
Next question. Azure Firewall relies on XSF header to identify potentially malicious source IPs?
Yes, it does. It will look at both the XFF header and also the and that, in case of if it's exactly as a source, it will look at the source, or in the other case, it will look also at the XFF header. So it will look at both.
Great. And we have answered all of the questions. Let me see, one more actually. Okay, one more last question. Would the topology look familiar if using a third-party WAF instead of Azure WAF?
Honestly, I don't think it would work. Andrew, maybe you can add to that, but as far as I know, I'm not sure about the integration with other WAF vendors when it comes to the TLS inspection for the WAF. So I would say no, but at least that's as far as I know.
Yeah, so again, we haven't yet tested it with third-party WAFs. Of course, the focus was on the Azure WAF and application gateway. So again, that's something we need to get back to because of course there's integration with the Azure file for the TLS inspection.
Okay, perfect. So thank you to Andrew and Saleem for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. Once again, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your feedback at aka.ms/AzureNetSecFeedback. Thank you and see you next time. Goodbye.